Hello, let's take a look at something called recursive sequences. Now, a recursive sequence is a type of sequence like a geometric sequence or an arithmetic sequence. However, it's kind of a different subset in that a recursive sequence can be a geometric sequence or it can be an arithmetic sequence. It's more the way you write it. And what is the definition? Well, a recursive sequence is a sequence that depends on previous terms to find the next terms. So it's all kind of in the notation, and in a recursive sequence, you're going to see a lot of a sub n's, a sub n minus 1s, a sub 1. To do well with recursive sequences, you're really going to have a solid grasp of our sequence notation, this stuff here, where we're labeling the terms of a sequence. And that will help you make recursive sequences really easy to read and figure out. Because I could have a sequence where a sub 1 is my first term, a sub 2 is the next, a sub 3 is the third term, a sub 4 is the fourth term. Right? We should be familiar with this notation where a sub 1 stands for a term in the sequence, specifically the first term because of the 1. And then when I talk about a sub n, well, that's talking for a general term in this sequence, and it could be any of these, because it's kind of just a general term, not specific, and then I can specify it by saying, well, let's go to talk about a sub 4. So a sub n is some term in the sequence, and we've seen that with our rules. We write a sub n equals, and then we say, what about when n equals 4? Well, what's a sub 4? Similarly, I can talk about a sub n minus 1, for example. And what's that talking about? Well, again, some general term, but this time, a sub n minus 1 is talking about the nth term and then one behind it, the nth term and then one before it. So example, a sub n minus 1, when n is equal to 4, well then a sub n minus 1 goes to a sub 4 minus 1 is equal to a sub 3. So when n is equal to 4, I'm talking about a sub 3 there, the term right before the nth term. And let's get some work with that to drill home that idea, because when we're dealing with recursive sequences, we're going to see that a sub n, the a sub n minus 1. Which that's talking about a previous term, so that's in recursives. And then with recursive sequences, you always need a starting point. You always need your a sub 1. Where do you start? Let's put that together in our first problem. Find the first 5 terms of the sequence in which a sub 1 is equal to negative 8, and a sub n equals negative 2 times a sub n minus 1 plus 5, if n is greater than or equal to 2. So this is a recursive sequence because I have my rule here where it says to find some nth term. How do you get there? Well, you have to know the term before it. That's what I mean when I say a sub n is a term and then a sub n minus 1 is the term before it. So in order to get the next term in your sequence, you got to multiply the term before it by negative 2 and then add 5. And then you also have to know where to start. You always have this starting point for recursive sequences because you got to know what your first term is to figure out the next. So I'll go a sub 2 is equal to, well, it's negative 2 times a sub 1, because you go with n equal to 2 and it's 2 minus 1 plus 5. And what is a sub 1? A sub 1, we are told, is negative 8. So the second term in the sequence would be 16 plus 5, which is 21. Let's look at a sub 3. A sub 3 is going to be negative 2 times a sub 2, because the term before it, plus 5 is equal to negative 2 times, well, what is a sub 2? 21 plus 5. So we get negative 42 plus 5, negative 37. That's our a sub 3. Moving on to the next term. A sub 4 is equal to negative 2 times the term before it, a sub 3 plus 5. Put in our numbers, negative 2 times what is a sub 3? It's negative 37. We can add 5. And we get that a sub 4 is equal to 74 plus 5, or 79. All right, and then the fifth term of our sequence. A sub 5 is equal to negative 2 times the term before it, so a sub 4 plus 5. Let me get our color coding back in order here, a sub 4. Okay, and plugging in for a sub 4, it's equal to negative 2 times 79. Numbers are getting pretty big here, plus 5. Negative 2 times 79 would be negative 158 plus 5, negative 153. And so we have our first 5 terms, negative 8, 21, negative 37, 79, negative 153. And then we got to see in work how our recursive sequence depends on the term before it in order to get the next term. Find the first 5 terms of the sequence in which a sub 1 is equal to negative 3. So I have my starting point. And a sub n is equal to 4 times a sub n minus 1. That is 4 times the term before it, minus 9. Well, what's my first term? Negative 3. So being smart, I can already eliminate C and D because they do not start with negative 3. And then let's lay it out. Okay, a sub 1 is equal to negative 3. A sub 2 is equal to 4 times the term before it, minus 9. So that one is equal to negative 12 minus 9, negative 21. A sub 3. 4 times the term before it, negative 21. Put it in there, and minus 9. 4 times negative 21 would be negative 84. Minus 9 is negative 93. A sub 4, let's keep going just for practice. 4 times the term before it, which is negative 93, minus 9. And 4 times negative 93 is negative 372. Minus 9 is negative 381. And once you get a flow of it, recursive sequences they're sort of fun to keep going with. I'm just taking the number for it, plugging in. It's got a nice rhythm to it. So 4 times negative 381, well, that is going to be negative 1,524. Minus 9, negative 1,533. We have our first 5 terms right here. And we see that the answer B correlates with our answers. So B stands for the first 5 terms. That's good practice in reading a recursive formula and being able to find the terms of it. Really important that we understand what a sub n and a sub n minus 1 is. You can even have a recursive sequence that is equal to maybe a sub n minus 1, so 4 times that, plus a sub n minus 2. There, the next term is reliant on the 2 previous terms, both n minus 1 and n minus 2. Once you get a good grasp of reading that sequence notation, the a sub n, it's really pretty easy to go and find the terms of the sequence. Next, we will look at terms of the sequence and write the recursive formula for it.